So we talked about the service discovery and the API there, and now I want to dive into sort of the more meshy stuff around Consul, the newer stuff. This feature set in Consul is called Consul Connect. This is where you get the mutual TLS and where you're going to get layer 7 stuff, and how does this come into play. So the things that Consul Connect gives, you could read this yourself, but the things that Consul Connect give you are sort of colored here. Automatic TLS encryption between all services. Identity-based authorization, so we're working with intents rather than IP addresses, and works everywhere. So we want this to be able to work on VMs, Kubernetes with physical switches, and edge gateways and things like that. And so this is the idea behind it. The problem we're trying to solve is sort of this idea that before you would do, so there's two problems we're trying to solve. The first problem is a security problem. The second problem is safely deploying more and more applications. I'm going to talk right now about the security problem. So the problem we're trying to solve is before, to protect conversations, communication between two servers, you would put a firewall and use IP as the identity. And that firewall would say yes or no. This doesn't have to be plain TCP. This could be a TLS. But what we found in practice is that TLS is hard, and so a lot of people internally in their company were just doing plain TCP because it's easier. I think as you get to bigger companies, you see more sophistication in terms of having PKI solutions and using more TLS, but it seems like that was viewed as an evolution rather than a default, and so this was sort of a common default. What we're doing with Connect instead is peering one level deeper and using the service identity as the actual point of protection. So in this case, in a previous static world, as we'd call it, pets versus cattle, when you have pets, you would say, my application is IP1. That's its home, that's where it lives. But in a dynamically scheduled world, IP1 might actually be the home to multiple things that appear. And so it might be both the API and the web server. And you might want to say, the API can talk to the database, but the web server cannot. In an IP world, that's relatively difficult because you would have to introduce some level, something, right? It's more complicated, VLANs or multiple networks or something onto the actual device, and it's much more complicated to manage. But this is what you're trying to achieve. And this is what Connect helps you achieve. And in doing so, also just automatically introduces TLS between every connection, and we'll show you how it does that. So Consul Connect is the components that make it work are really these three things, the top three things, and then it's easy to use. Is a service access graph. So we already have the service catalog of everything in your data center. They don't need to participate in Connect, but we have the full catalog. And so you're able to use that catalog to now start forming access graphs and use those as rules of who can and cannot communicate. It's a certificate authority, so we want mutual TLS. We need to solve PKI. We need to issue certs. So Connect integrates its own built-in CA, which sounds crazy, but we also build Vault, and Vault is a CA for some of the world's largest companies. So we brought that functionality directly into Consul, leverage the same stuff. But also, realistically, you're not going to use that. I think that's a great way to make it easy to use and easy to try. But in a real-world environment, due to compliance reasons or whatever, you're going to have a separate CA vendor. You're going to have more complex things where the root is air-gapped. You have intermediates. You have more complexity. So the CA system is completely pluggable. It integrates with Vault. Vault supports that model, but it also integrates with things like AWS Certificate Manager, Venafi, other systems there. So the CA is pluggable, but in line with our philosophy of making things easy to use and having a low barrier to entry, we ship with one out of the box. So you have single binary experience to make this work. And then finally, it's a pluggable data plane. Connect is a control plane solution. We don't want to be the proxy. We don't want to be in the business of writing actual proxies and load balancers and so on. So that's a pluggable API. We integrate first class with Envoy. We also have integrations with HA Proxy, and we're talking to other vendors, such as F5 and others, to integrate directly with them to make this all work. I think, yeah, go ahead.
So in terms of access between different services, is there a policy that you're generating somewhere to say, this service can talk to this one in like a declarative way?
Yeah, that's the service access graph.
Okay, so that's essentially what that is doing. It's a policy engine.
Yeah,
okay.
Totally. And a fun part about it is you could also create policies for services that don't exist yet. And from a human point of view, this is important so that you could have network security or your security team be approving access connections before you're ready to deploy the application. So you don't get this waterfall approval ticket process. You could actually say, like, I intend to deploy this application. Please open the rules up. It'll be ready in a few months. And hopefully by the time you can deploy it, you've already been through the network security process.
Is it relatively straightforward for someone in compliance or network security to understand how to craft one of these?
Yeah, I think I show.
Is it a YAML file?
Yes.
No comment. Yeah, I'm going to show you an example right here. Or
Okay.
I'll just show you an example right now. So we have a UI for Consul. It
Yes, that's
looks
for
roughly
compliance
like this.
officers. Yes.
Yeah, I mean, I think this is actually a mock-up from before we released it, but it exists now and it looks a little bit different. But this is the best screenshot I had. There's now priorities and some other things in here. But I think to somebody who is a networking person, by whatever title they have, but a networking person, this little table with numbers and priorities will look very comfortable and familiar to them.
Is there or will there be a sort of a discovery process for this? For example, if you're retrofitting Consul into a pre-existing environment and it looks into already communication that's already occurring and then builds up this rule set that you then approve or disapprove.
Like VNI?
Sorry?
Like VNI?
Exactly, that kind of thing. So
Potentially.
Interesting.
Yeah, that doesn't exist today. We have a feature in Vault that we announced 2 years ago. Well, we announced that we're working on it 2 years ago. We started betaing it last year. But we have this feature in Vault called Advisor, which what Vault does is look at actual secret access patterns. Because just really quickly, security, if your policy is too generous, it's just a risk. But if your policy is too constrained, it's flat out broken. And so people tend to make these overly generous policies, claim that they'll shrink them down and then never do, right? And so you end up with unnecessary risk all over the place. We built this system called Advisor. It's I think other startups would be like, it's machine learning, it's crazy, but it's not. It's complicated, but it is a learning process, and it recommends policy minification to the operator in order to be more secure. We built that system in a generic way, so we could hopefully bring it to our other products, and we aren't doing it today, but we are talking about that exact use case of the default should be let anybody talk to anybody to get started, and we'll tell you what the initial set of intentions probably should be. Yes. I think another answer to that is at our conference this year, which was a few weeks ago, we announced that we worked with VMware as an example on federation with NSX SM. And I think the idea there is that for your physical infrastructure, you might be using NSX and have the rules in there, and you don't want to have to duplicate them to Consul, but Consul is probably the better solution in the cloud or in different environments. So we'll federate those rules between the two, so you don't need to duplicate them.
So is this also where the HA proxy, working with HA proxy comes into play as well?
They
Same
consume
integration
these.
point?
Yeah, they consume these, but they have to do other stuff too, because HA proxy needs access to
needs all that,
certificates
yeah.
and other stuff.
Yep, okay.
Yeah, this is more just who could talk to who,
Gotcha.
not assigning identity.
Gotcha.
Now, as you're knowing who can talk to who, is there any comprehensive, or doesn't have to be comprehensive, is there any type of audit trail, so when you have to provide that data over to compliance? And I mean, I've been seeing ITAR pop up more in the past year than I have ever, and the ability to provide that detailed paper trail of who was talking to who, where, why, what, etc.
Yeah.
Do you actually have that exposed in some manner to actually extract that type of data?
We do not, but it is on the roadmap in the near term. We're working on it. So I think we took this strategic decision to make it work first, knowing that it wouldn't work. There'd be checkboxes we don't fill for day two, sort of like actually putting into production experiences, and we're catching up on that now.
So are you going to talk about, when we're talking about cloud services, so it's great that you guys abstracted away from going IP to IP. That's a model that's just broken. But even when I'm talking service to service, so the common use case that I give is I have AWS Lambda talking to a Oracle database on my on-prem. That service is allowed, but what it does and what it can do is a bigger problem versus whether or not it's allowed. So can you talk about the two things? One, how do you protect or identify or allow that type of traffic? And then two, how do you get to the next granular piece, because when I ask clients, yes, you've allowed Lambda, but do you know what it's doing to your Oracle database is a bigger question. So where you guys play in that space?
Yeah, so I think the question you're asking is more of like layer 7 level permission, like going into the layer 7 traffic to
So
figure out.
the second part is going into the layer 6.
Right.
So that's a tough one.
Yeah.
The first one, though, is a basic, you know what, I have a cloud service, and that cloud service is accessing a node or a service on a target in my data center.
Yes.
And I want to control that access.
Yes, let me skip slides now. It's worth skipping slides for this. Nope. Okay.
900 slides?
Yes, no.
You lied, man. You said
The door is locked. Yeah, okay, so I'm going to talk about both. Let me talk about the actual physical networking challenge first of that, because I think you hit on, and I'm happy to be in this group, because the challenge I see is there's a lot of people that are building solutions that do this, that are solving the networking challenge in a hermetically sealed environment. It's Kubernetes only, it's VMware only, something, and I just don't think that's a hard problem. I think that's like a problem that people have. You could get more automatic TLS. There's things you get from that, but the problem that I'm hearing from talking to customers, and I'd be curious if this is mirrored, is the challenge of I have stuff in the cloud, I have stuff on-prem, I have stuff across the world, and Kubernetes is introducing forced overlay networks, and what am I supposed to, how do I get the bits to flow, is the problem. So this year, this is all out now, this is all available. We announced this feature called Mesh Gateways. They are built into the Connect system, and they do automatic cross-network, cross-data center gateways to traverse service mesh traffic. It retains the full end-to-end encryption from one side to the other. The actual gateway devices cannot decrypt the traffic. For companies that need to decrypt the traffic, we're working on some stuff, but in the model today, they cannot decrypt the traffic. And it works, it allows you to traverse these different environments. So it's what you would expect, right? Like you have this, and let's say one side is the Lambda, and then the other side is your physical data center, and it actually went through a third data center in the middle to go through it. You end up just putting these mesh gateway devices on the boundaries of that network, and we do the IP translation for you. And we don't need to preserve the original IP address or anything like that. That's complicated because the identity levels of the service. So as long as we preserve the TLS signature and the TLS headers, that's all we need.
This is all dependent upon having an agent on those devices, right?
The gateway?
No, each of the devices that are talking to each other over the TLS, they all have the agents running? Or
They need to be participating in Connect. The easiest way to participate in the service mesh is the agent and the sidecars, because we could automatically wrap traffic within a network namespace and do that. You don't need to.
How does that work with something like Lambda, though, where it's serverless?
Yeah, so so we this isn't released yet. We're working on some stuff where we'll wrap the traffic. If there's an acceptable risk to get to that gateway device, we'll wrap the traffic at the gateway device.
Okay.
Yeah, and we're looking at other things where if you can rewrite applications, if you integrate an SDK, you could actually do it in the function.
Okay.
We do have that capability, but I think practically that's unlikely.
Yeah.
Yeah, so this ends up being what happens is you have Kube, let's say that's Lambda, you have EC2, you have VMware, and they have to hop through to get to your on-prem data center. You put a gateway device on each one, and we handle the traffic for you, is how it would work in Connect. And again, I think service mesh is moving really fast. I don't pay attention every day at how people are moving, but we announced this in June. This was available in June, and as far as I know, we were the only people that were looking at this problem as the problem, right? Like, people are building bigger and bigger features within a certain world, and we're trying to make your networking work across different environments.
All the examples we're using IPv4.
Yeah.
Does it work equally well with IPv6?
I believe so.
And
Yeah.
is it IPv6 native?
I don't know. I mean, so we have people using Consul with IPv6 only, and 2 years ago we went through a lot of pain to make all of Consul work with IPv6, necessary pain. The Connect stuff is so much newer that I'm not sure how everything is working. Okay, let me just fall back to around here. That's cool. We get to skip those later. Okay, so one other benefit I want to talk about with the service access graph and intentions is that they're scale independent. And that's pretty important, is because it enables us, even with the largest deployments, we can more or less cache the graph almost completely. We don't, but almost completely on the edges, because if you have 50,000 web servers and 5 databases, that's still one rule. That's still a really compact rule versus IP addresses where at the worst case it'd be 50,000 IP addresses, or you're trying to force microsegmentation in their CIDR blocks, but that's another complexity that you're trying to introduce.
I've got an internet question. Someone's
Okay.
asking can it manage egress traffic from a node? The concern around lateral movement or data exfiltration from a compromised instance or container.
In what? I'm sorry, I'm not.
As a means of where it can allow, deny, or have introspection into that. So you can, one, the egress side of growth of egress is expensive sometimes, but also if it can identify bad actors going on, and it can try to stop that exfiltration activity from occurring. I'm just trying to infer from the question because that was their question.
Sure. So the mesh gateways will only forward traffic that looks like connect data, right? Like it has to be TLS. It has to represent, the identity has to map to a service that is a Consul service. So you have that protection. We currently today cannot introspect on traffic. So if the TLS cert looks okay and the TLS cert is signed by someone we trust, we pass the traffic through. But other than that, like normal traffic can't go out. There's also a configuration you could set to say that for this service or this machine, never ever use the mesh gateway, even if the database moves from local to, well, database never going to move, but if some service moves from local to a data center and now it has to go through a mesh gateway, you could say never do that, even if that's the way you get the bits through. And so I think those are the 2 protections we have.
Okay.
Actually, that's the default behavior. You have to opt in to allowing your agent to use mesh gateways. Cool. Yep, so you manage these intentions with this or CLI or an API. They all flow back to the API. And as you would expect, we use sidecar proxies. I think every service mesh uses sidecar proxies. It's the easiest way that you don't have to modify your application to get this to work in the most secure way possible. So, client will talk to the proxy. Let's see what's happening here. There's too many animations. All right. Yes, there's so many animations. Let's just get to the final one.
That's 899 on your slide.
That's their 900 slides. Are these? So what's happening here is the web service is trying to talk to the database, right? So what ends up happening is instead the web service talks to a local proxy in a Kubernetes environment or in other containerized environments that's within the context of a single network namespace to lock it down. And then it's getting the TLS certs from the client. It has privileges to get those certs. It establishes a mutual TLS connection. The proxy verifies the signature and establishes this end-to-end connection. So there is a necessary overhead here, or it's not necessary, but there is an overhead here. It's relatively small because these 2 connections are just loopback connections. And also, again, we use that client model in a very important performance enhancing way to edge push these TLS certs. So the rotation of the TLS certs and everything that's happening happens in the background so that the hop path of I need my TLS cert is just an in-memory lookup and here's your cert. And same with when the DB says, okay, I got something from web, is that allowed? Checks the intention. Those are all cached as well. So the overhead is quite small.
Is there any notion of connection pooling there? Like so that you could keep that connection up into a pool so you didn't have to reestablish the connection every time?
It is. It's all that way.
Okay.
So all connections between proxies, clients, and servers happen over a long-held gRPC connection. Yeah.
So do you set? I'm trying to think how I want to say this. So do you set the gateway for your? Oh no, you're talking only containers, so it's a little bit different. But I could do this with VMs. Let me just say from VM's perspective. If I want to use the proxy, I know you say the client is configured to talk to the proxy and all that. Obviously, when I start routing to my application, my database, things like that, do I need to configure, say, for example, my gateway? My default gateway, does it need to go to the proxy to handle the communication?
No, to an actual, not a mesh gateway. To an
Right, not in the mesh gateway.
A real network gateway.
Exactly.
To it, it's just going to look like TCP traffic between 2 IPs, right? So I think what ends up happening is this is compatible. You can bolt it on top of something like a micro segmented network, but you're going to want to start not micro-segmenting that network to let this traffic through, because it's all going to look black box to it.
Okay.
Yeah, you slowly move the IP-based firewall rules into intent-based ruling.
Yeah. Okay.
Cool.
Hopefully
Okay.
that made sense what I was getting at.
Yep. So I talked about the performance. I think this is really important because, again, as far as I know, as of June, we were the only system that did this edge-pushed background rotation mechanism. So there was almost no cost to the two connections. But I'm not going to say we are. I don't know. Okay, so the last couple things, I'm going to move pretty quickly. That was a security angle, mutual TLS. But there's also all these other features in meshes today, which is layer 7, which has almost nothing to do with security. But the challenge this is solving is something that an analyst termed, and we like, called progressive delivery. The idea that we need something that limits risk to deployment post CI/CD, because as much as we'll try in the CI/CD process, we're going to ship bugs. And so how do you actually limit that blast radius? And this term encapsulates a bunch of practices such as canarying, feature flags, rolling deploys, et cetera. Service meshes are a good place to introduce this. So in Consul Connect, we support, and this is all fully released, layer 7 features around HTTP, gRPC routing, traffic splitting, and custom service resolution. I'm just going to go quickly to show you what that looks like. So I mentioned this earlier, but by default, when you ask Consul where the web service is, it just finds the healthy ones and returns them to you. You could also introduce any number of these, one or all of them, to do routing, splitting, and resolution. And it happens, this is how it happens. We call this the discovery chain, and we do it in this order. And so what you're able to do here is say, okay, a web request came in, web service console. If it's HTTP, and it's requesting the /admin path, actually rewrite the routing to the admin service and rewrite the path, strip the admin prefix. I'm going to skip the config just to move quickly. After that, you can move into traffic splitting. And the traffic splitting for this might say send 10% of traffic to a subset of the admin services known as V2 and send 90% to the default. And then finally, you get to custom resolution, which is, okay, I know I need the admin service. I know I need the V2 subset. What does that mean? And the resolution step will say if there's metadata, which is key value, that says the version equals 2, then it's V2 subset, otherwise it's V1. And then finally, at the end, you end up returning these services all the way through. So you could return, you could configure these or not configure these for any service and enable this progressive delivery functionality. So this is where you're starting to get, as you crawl, walk, run, the first value you're going to get out of service mesh is TLS connections and strong identity and eventually audit logging and these capabilities. But once you got that in place, you could just keep going and you could get progressive delivery and you could do this piecemeal. This doesn't need to be big bang.
In its current state, would you compare this as a competitor to VMware NSX, or is that your end goal, or do you see that as something that could stand up to NSX right now?
I don't know. I'm so problem oriented. I don't, I don't look too closely. Do you have a comment on NSX?
So as Mitchell mentioned about, we actually federate with NSX Mesh, which is actually built on another open source project. Mm-hmm. But in the private data center part, I think we're tackling the problem at different layer. NSX about virtualizing the network automation, but we're building a connection between the actually ephemeral applications with the IP layer. So I think we're probably playing at different layers, but probably solving the same type of problem.
Exactly. You're solving the same problem, but from at different layers. So I'm curious as to how you're positioning this. Like for the use case of you have a brownfield deployment of something with VMs and physical boxes, and how would you say, okay, well, this is a good use case for that if you didn't have NSX or if you did have NSX?
Yeah, I mean, I think the best example is probably cloud, where you don't have NSX. Is it obviously enables?
Unless it's VM. Well,
unless sure. Okay,
let's XT.
Yeah. Sorry. Yeah. Okay. But the feature set obviously enables you to eliminate sort of microsegmentation and many IP rules. I think you have to have some, but they become very basic. But I think that's an extreme, like, you're a very progressive company at that point. I think the realities of sort of the existing ecosystem of solutions and network middleware and compliance, checkboxes and stuff will require that stuff for the foreseeable future. And so, practically speaking, I don't view it. I never tell a customer, our goal is for you to replace all that stuff. I think our goal is to move some of the functionalities, replace some of it for sure, but for these reasons. And when it makes sense, if you're using something like NSX SM, where you have a good solution on-prem, like we don't try to replace that. We just say, let's just federate to that and make that work. So it's hard because I think some progressive people say, cool, I don't need this stuff anymore. And you could maybe not.
Well, it depends, but what would you present? What's the perfect use case?
However company gets the most value out of it.
It's the perfect problem.
Yeah.
So I love like the architecture, I love the thought and building. I compared the presentation so far as you guys have built a beautiful box of Lego that you can build some very intricate solutions, but I'm not as geeky as most of the people around the table. While I have an appreciation for the complexity and the problems you guys solve from a operations and complexity problem for installing and operating a service mesh, I'm not getting why I need this from the beginning. I'm missing, this looks really cool, but when I hear it, I'm like, oh, you know what, NSX, ACI, a bunch of other solutions already do what I need to get done in the data center today. I'm sure you're going to get into it at some point, but it would have benefited me personally to have just heard the use cases first and then the how with the technology.
That's good feedback. Can I answer that?
You got 1 minute.
Oh, great. So yeah, actually, let me just explain a high-level use case. I think I only have time for one, but it's someone who talked at our conference last year. I think the bigger industry challenge right now is taking the existing practices, and I've picked on it a few times, but stuff like microsegmentation, and just bringing that practice wholesale into cloud environments and the challenges that introduces. So one of the first big adopters of Consul for this use case was a bank in the UK. They gave a talk, but I'm not supposed to mention them outside of that, so you could look it up. A bank in the UK where they were talking about how their problem to deployment was that they have infrastructure automation to some extent. They could deploy in theory in minutes, but the issue is that they have so many VPCs and there's AWS. They have so many VPCs. They have so many subnets. They have so many VPCs. They need multiple accounts to have more VPCs because they're trying to give these micro-segmented CIDR blocks that they're not getting utilization out of Kubernetes because it has to map to these things. Segmentation was just not working for them because it was slowing down the deploy of how do we constrain this to get to the right place, to get the right firewall rule, to get the traffic to route to the dependent services. That their challenge, I think this is pretty extreme, but their challenge is after they had an app built and they knew all the things they needed to talk to, it took about 6 weeks for their networking team to reason about what firewall rules and what placement they had.
That's not too extreme.
Okay, yeah. So that's what they were contending with. We got Consul in there in 6 months, and we were able to flatten that part of their network, which was their cloud network. We were able to flatten it. They eliminated $10 million of software load balancers pretty much instantly, and use these tools instead.
Yeah, you buried the lead.